So, Assalamu alaikum. This is Gul Saeed, and welcome to my YouTube channel, Chemistry with GS. So, today we'll discuss concepts of acid and bases. First is Arrhenius concept of acid and bases. So, according to Arrhenius concept of acids and bases, an acid is a substance that, when dissolved in water, increase the concentration of hydrogen ion. Right, so the hydrogen ion is called hydrogen ion is actually chemically bonded to water, that is H3O plus, and called the hydronium ion. So we have already uploaded this video before, right? So hydrogen ion plus H2O gives H3O plus. So the hydronium ion H3O plus actually exists is a hydrogen bonded cluster, right? H9O4. So this is this is water, this is H3O plus shape, and its shape is trigonal pyramidal. Now, what are Bronsted acid and bases? So Bronsted-Lowry concepts, an acid is a species that lose a proton, and it means hydrogen ions, while base is a species that accept proton. So HCl, for example, HCl, when ionized in water, so it produces hydrogen ions plus chloride ion. And H2SO4, when ionized in water, right, so it produces hydrogen ions plus sulfate ion. And NH3 takes hydrogen ions to produce hydrogen, NH4 plus ion. So this is ammonium ion, right? Now, Bronsted-Lowry acids are so Bronsted-Lowry base, right? So Bronsted-Lowry acid when reacts with Bronsted-Lowry base, so Bronsted-Lowry acid, it will produce conjugate base, and base will produce conjugate acid. So this is conjugate pair, right? So acid will produce base and base will produce acid. For example, water, when react with NH3, right? So water will donate a photon and NH3 will pick a photon and produce ammonium ion. Now this NH4 plus is able to donate a photon. It has hydrogen ions, so it is called a conjugate base. And OH ions, that is conjugate base. So the question is now conjugate acid can be defined, right? So conjugate acid can be defined as when an acid donates a proton to a base. So the resulting species is called conjugate acid. And conjugate base can be defined as when a base accepts a proton from an acid, and the resulting species is called conjugate base. Now, conjugate acid and bases, look at, so this is HCH3COOH, right? So this is weak acid plus H2O, this is base, so it is weak, not strong. So but water acts as an acid as well as a base that is called amphiprotic. So here, weak acetic acid is stronger than hydrogen in water, so it will donate a proton. So acetic acid will donate a proton and will produce acetate ion, CH3COO minus. This is strong base now. So here, water, it accepts a proton from this one, so it produces hydronium ion and strong base. Here, one thing to be noted, that weak acid produces strong base, conjugate base, and weak base produces strong conjugate acids. So look at, when an acid gives away, remove hydrogen from an acid and gives us conjugate base, when that hydrogen is added, is returned to the conjugate base, it produces acid again. Like HF, when hydrogen is removed from this one, so it produces H minus ion, right? And H2SO4, when hydrogen is removed from this one, so it produces conjugate base HSO4 minus, and NH4 plus, right? It can donate a proton and remove, when a proton is removed from this one, so it produces NH3. And the same way HCO3, this is hydrogen carbonate ion. When hydrogen is removed from this one, so it produces CO3. This is conjugate base. When hydrogen is added to this one, so it produces again this as well. Now the third concept is Lewis acid and bases. Lewis concepts of acid and bases. So what is Lewis acid? And any an acid is an electron pair acceptor and base is an electron pair donor. Example, this is BeF2, not Be, this is BeF2 plus 2F. So it produces BeF4 minus 2. In the same way, H plus F minus ion, so it produces HF, which is an acid. So here an acid is electron pair donor to form coordinate covalent bond, and base is an electron pair. Base is an electron pair donor to form coordinate covalent bond, and acid is an electron pair acceptor to form coordinate covalent bond. So here it is one bit. Here you see the negative sign, so it has sufficient electron to donate. So it is Lewis base, and that electron will be accepted by BeF2. So it is Lewis acid. Here H plus, so here F minus ion. So F minus ion has sufficient electron, has a pair of electrons to donate, right? So that a pair of electron takes what's hydrogen. So it is pair of electrons acceptor, because without pairing of electrons, there is no covalent bond, there is no bond. So if hydrogen wants to make a bond with fluoride ion, so a pair of electrons will be donated by fluoride ion to hydrogen and will form a molecule HF. Now look towards Lewis acid and bases concepts. Advocate a substance, atoms, ions, or molecules which is capable of accepting a pair of electrons. So a substance base, a substance which is capable of donating an unshared means lone pair of electrons to form coordinate covalent bond is called Lewis base. Okay, this is an acid, this is base, right? So